Natalie, and this is the first lab on charge tapes for Physics 2. So for the introduction, here are my purpose and results. The purpose of this experiment is to create charged pieces of clear tape and then determine the excess charge on the tape. And a quick preview of my results. Charged clear tapes have net positive charge and they repel one another. And we can conclude that they had positive charges because they were attracted to a negatively charged pen. The calculated charge on the tape was 1.11 times 10 to the negative 8th coulombs, and the magnitude of excess charge calculated was 6.94 times 10 to the negative 10 electrons in excess. Quick introduction on the background and some fundamental principles. Ordinary objects gain excess/deficit of charge if they are rubbed, pulled, or touch other objects. And this is given to us in the lab, but the absolute value of net charge should be in between 1.6 times 10 to the negative 19 coulombs and that number times Avogadro's number, which is 1 times 10 to the 5 coulombs. And some key equations, which are sort of also concepts, are Newton's second law, which is force equals mass times acceleration. And in this lab specifically, we use the force of gravity in terms of F. And electric force, or Coulomb's law, I spelled that wrong, which is F times the K constant, which I completely wrote out here, times both of the charges over radius squared. And so to create the tapes, you have to make the base tape by taking a strip that's roughly 20 centimeters long, folding it over the end of the strip to create a handle, and then stick the handle onto the smooth surface. You got to make sure the smooth tape, just to tape the smooth base down, and then you make a U-tape shape by taping another tape. I think I meant to say making, sorry, with handle down on base tape and then smooth it again. And here are the figures given to us in the lab that further demonstrate how to do it. And after doing so, these are some observations I had later once I began the experiment, that the tapes repel, which means they have to have the same charge. They were attracted to a negatively charged pen, meaning that they must have a positive charge, and there's a small attraction to neutral objects, books, which is the case for any charged object. It'll always have a small attraction to neutral objects, but not as much as it would to something of the opposite charge. And these observations were after I created the experiment. This is just creating the tapes. Okay, some key assumptions I made when I was carrying out my calculations. Air resistance was negligible, and the charges on both pieces of tape were equal, and the tapes were point charges for calculation purposes because we don't know enough about haven't been taught surface area in terms of charges and things like that. And the charge is evenly distributed, and the mass of the tape was 0.002 kilograms, and this is because the mass of the tape is equal to gram times the tape length, and we used 0.02 meters as the tape length. The experiment was to create this floating U-tape over another U-tape. The system was tape B and the surroundings were tape A. And to calculate the distance D, this is kind of what we did. And yeah, I used the meter stick to do it. Some key calculations and models. After drawing the free body diagram over here, you realize that the electric force and the gravitational force are equal to each other. And here I have the 3 trials I conducted to calculate the distance, and then I took the average, and that's what I ended up using. And then here is the way I solved the problem, set the forces equal to each other, and then we can assume that QA and QB, since the charges are equal to each other, they're the same value pretty much. And then I plugged in the values, and I found that the charge on tape A and tape B was 4.72 times 10 to the negative 8th coulombs. And then these are some of the other calculations we had to carry out. The number of electrons on tape B, number of atoms total. The number of electrons on tape B I calculated by taking the charge calculated in the previous slide and dividing it by the charge of a single electron. The number of atoms I calculated by dividing the area of the tape divided by the area of the atom. I flipped those around, my bad. And then the ratio of electrons to atoms was number of electrons to atoms. The number of electrons on tape B divided by the number of atoms. And here is the glow script code. And here's my conclusion, which is things that I've already said, but I'll restate again. The charge clear tapes have a net not positive charge because they repel one another, and you can conclude it's positive because of the pen. Here are the values that were stated, and we also know that both tapes had equal charge, and they were both positive. And yeah, that's about it. Thank you.